All right, I'm just going to give you a little overview of the Chapter 4 Atomic Structure test to give you a sense of what will be on it and the types of questions. First of all, it will be, this is the test I gave last year, the new one will be very similar. Looks like about 20 or 19 multiple choice questions, and then a short answer question, which I'll describe in a minute, and a numeric response question. So let me go over the gist of the multiple choice questions first. First one is a vocab term, so make sure that you know what atomic number and atomic mass and mass number are, as one of those shows up in this first question. The second question asks which of the following is not a part of Dalton's atomic theory. So make sure that you know those 4 principles of Dalton's atomic theory, that all matter is made of these little tiny indivisible particles that we call atoms, that all the atoms of an element are identical and different from atoms of other elements, etc. It's in the chapter. I think it's in section 4.1. The next question has to do with the subatomic particles in an atom and the properties, or what is the charge on an atom, how many protons are there, how many neutrons, how many electrons. This is something that would be true for all atoms. So a statement that could be said to be true for all atoms. Next question is about properties of subatomic particles. That has to do with their charge and their mass. So make sure that you are familiar with the table that we wrote in class and which also is in the book, listing the relative mass of each subatomic particle, protons, neutrons, and electrons, and their charges and where they are, where they're found in an atom. The next question is about isotopes. And it shows some chemical symbols, and it asks which symbols represent isotopes of the same element. So make sure you know how to tell if 2 chemical symbols are for the same element. If you didn't have the letters in the symbols, obviously if they both have C for carbon or N for nitrogen, you would know they're the same element. But if it was just an X, and it was listed with the atomic number and the mass number, how would you know which were the same element? What would you look at? Think about that. The smallest particle of an element that retains the properties of that element is blank. You can read the chapter and think of that one. I think it's also in the quizzes that you just completed. What is the definition of atomic mass? I already mentioned that you need to know that when I talked about question 1. What particles are found in the nucleus of an atom? Make sure you know that. Next question, how do you calculate the number of neutrons in the nucleus of an atom? What information would we need to know? Do we just look at a symbol, or do we have to do some mathematical operation? You filled in some tables and were able to calculate the number of neutrons. So it's something you've done in class. Look back in your notes if you're not sure. A specific example, how many protons, electrons, and neutrons does an atom with such and such an atomic number and such a mass number contain? So you should be able to figure that out. Which of the following statements is not true? Okay, I'm not going to tell you what the statements are, but they concern the masses of atoms, they concern isotopes, they concern properties of the nucleus, and just general structure of an atom, having a nucleus and having electrons around it. So one of the statements here is not true. You'll have to think about it and figure it out. How do the isotopes of hydrogen 1 and hydrogen 2, those are 2 isotopes of hydrogen, how do they differ? And there are 4 choices there about their structures and the particles they contain. What did J.J. Thomson discover about the atom? So that's a good question. Think about what his discovery was and what model he came up with. So be familiar with that. Also be familiar with what Ernest Rutherford discovered about the atom, because maybe I'll change this question and put something in about Rutherford instead. But again, this is just the gist of the test from before. All atoms of the same element have the same blank. So what is it that atoms of an element have in common with one another? As a consequence of the discovery of the nucleus by Rutherford, what new idea was added to the model of the atom? So there are several descriptions of models of the atom. We want to know what it was, what the model of the atom was after Rutherford discovered the nucleus. Which of the following statements is not true? This concerns the properties of subatomic particles. Again, if you're familiar with the table where we listed proton, neutron, and electron in terms of charge and mass and location, then you should be able to answer this question. Dalton hypothesized that atoms are indivisible and that all atoms of an element are identical. So there I'm giving you two of his postulates or axioms of his theory. And then it says, it is now known something about Dalton's theory that more recent knowledge could be used to describe John Dalton's theory. I'm not going to tell you what the choices are. But again, a lot of these things you have to just put a little thought into it. You have the information, you just have to think about it. Isotopes of the same element, how do they compare? What do they have? What's the same and what's different between isotopes of an element? And then finally a question relating to the definition of atomic number, just like I mentioned earlier. That's all the multiple choice. In the short answer questions, I have a table, and in the table I list 3 isotopes by name and mass number, and I ask you to provide me with the number of protons and the number of neutrons for each isotope. Fill in the table. And then in a third column, or I guess a fourth column, I provide you with the abundance of each isotope. And you have to, in addition to filling in the table, you need to calculate the average atomic mass. That'll be the weighted average. That's what we did in class, where you multiply the percent times the mass for each isotope. Okay? So you do have to do a calculation like that. And then last question, I say use the periodic table to determine the number of protons, electrons, and neutrons in an atom of some specified isotope. So that's the test. You are allowed to use a periodic table. You can always use a periodic table. If I don't mention it, you can always use it. I'll never make it so you can't use a periodic table. But you may not use any other resources, any friends, Google, anything else. Okay? And that's it. The test will be available to you in Illuminate, and I will set a fairly wide window for when you can start the test. But once you start the test, you'll have 50 minutes, 50 minutes to complete it. And then I have to grade the last couple of questions because they're going to be constructed response. So the grade, I don't know if you get a grade right away or not in Illuminate, but it wouldn't be your final grade anyway because those problems wouldn't have been graded yet. So I hope that's useful information for you. Be sure to study, and I will post in Google Classroom what the testing window is when you have to log into Illuminate and take the test. Good luck. Bye-bye.